Today we are going to learn about mastering NumPy Broadcasting for efficient computations. You'll acquire skills to utilize NumPy Broadcasting to perform efficient and memory-saving computations, crucial for handling large datasets in data science and machine learning. Welcome everyone. In this video, we'll dive into the world of NumPy Broadcasting. Broadcasting is a powerful feature in NumPy that allows operations on arrays of different shapes without explicit loops. This technique is pivotal in data science and machine learning, where handling large datasets efficiently is key. Broadcasting leads to more readable code and saves memory by avoiding unnecessary data duplication. By mastering broadcasting, you can optimize your computations, making them faster and more efficient. Let's explore how broadcasting can transform your approach to data handling.
To begin, let's define what broadcasting means in the context of NumPy. Broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. The simplest example is adding a scalar to an array. NumPy implicitly expands the scalar into an array of the same shape as the one being added to. This principle extends to more complex operations. For instance, if you have a 2D array and a 1D array, NumPy can stretch the 1D array to match the 2D array dimensions, enabling element-wise operations without explicit loops. The real advantage here is efficiency. Operations are performed in C, underlying Python, which is much faster than a native Python loop. Understanding shape compatibility is crucial for mastering broadcasting. For two arrays to be broadcast together, their shapes must either be the same, or one of them must be 1. NumPy starts with the trailing dimensions and works its way forward. If dimensions are unequal, the smaller dimension is stretched to match the larger one, provided the smaller is 1 are compatible. For a practical example, consider a 3x1 array and a 1x3 array. These can be broadcast to a 3x3 array. This flexibility allows for efficient computation across various datasets, but be cautious of incompatible shapes, which will result in errors. Always check the shapes before performing operations to avoid broadcasting errors. Let's look at some practical examples, starting with addition. Imagine you have a matrix, and you want to add a constant to every element. Broadcasting makes this straightforward. Simply add the scalar to the matrix, and NumPy handles the rest, expanding the scalar behind the scenes. For matrix addition, consider adding a 3x3 matrix to a 3x1 column vector. Broadcasting enables this by extending the column vector across the columns of the matrix, performing element-wise addition. This eliminates the need for cumbersome loops and results in cleaner, faster code. By applying broadcasting, you not only save time but also improve the readability and efficiency of your code.
Next, let's explore multiplication with broadcasting. Consider multiplying a 2D array by a 1D array. With broadcasting, the 1D array is stretched to match the dimensions of the 2D array, allowing for element-wise multiplication. This technique is particularly useful in data normalization tasks or when applying weights to datasets. Broadcasting ensures that operations are not only faster but also more intuitive, compared to traditional nested loops. It's vital to ensure your arrays are compatible, otherwise, you'll encounter shape-related errors. Always check the dimensions and leverage broadcasting to perform complex operations efficiently, saving both memory and computational resources. While broadcasting is powerful, it's essential to be aware of common pitfalls. The most frequent issue arises from shape mismatches. If two arrays have incompatible shapes, NumPy will throw a value error. To avoid this, always verify your array shapes beforehand. Another pitfall is misunderstanding implicit dimension expansions. NumPy expands dimensions automatically, but this can lead to unexpected results if you're not careful. Use the np.newAxis feature to add dimensions explicitly, ensuring clarity in your operations. Regularly check your code for potential broadcasting errors, and make use of NumPy's shape attribute to confirm compatibility before proceeding with operations. One of the main benefits of broadcasting is memory efficiency. Traditional methods might require duplicating data to perform operations, leading to increased memory usage. Broadcasting, however, allows you to perform operations without making copies of data, thus saving memory. This is particularly advantageous when dealing with large datasets, as it minimizes memory footprint and enhances performance. By eliminating the need for temporary arrays, broadcasting optimizes resource use, allowing you to handle bigger datasets without running into memory issues. This efficient use of memory not only speeds up computations but also reduces the cost and complexity of data processing tasks.
In data science, broadcasting is a versatile tool that simplifies many common tasks. For instance, in data preprocessing, you can normalize or scale datasets efficiently by broadcasting scalars over 1D arrays across larger arrays. This is crucial in preparing data for machine learning models. Broadcasting also plays a role in feature engineering, where you might apply weights or biases to datasets. By leveraging broadcasting, you can perform these operations succinctly, reducing complexity and increasing code readability. This ability to simplify complex operations makes broadcasting indispensable in the data science toolkit, allowing for more efficient and effective data manipulation. When it comes to performance, broadcasting has clear advantages over traditional loops. Operations that rely on broadcasting are executed in C, making them significantly faster than Python loops. This speed difference becomes more pronounced with large datasets, where broadcasting can reduce computation time dramatically. Additionally, code that utilizes broadcasting is often more readable and concise, which improves maintainability. Resource utilization is also better with broadcasting, as it minimizes memory usage and avoids unnecessary data duplication. In contrast, native Python loops can be slow and resource-intensive, making broadcasting the preferred choice for efficient data processing. Debugging broadcasting errors can be challenging, but with the right approach, it becomes manageable. Start by understanding the error messages; they often indicate shape mismatches. Use the np.newAxis to explicitly add dimensions where needed, ensuring clarity in your operations. Always verify the shapes of your arrays before performing operations, and make use of the shape attribute to confirm compatibility. Common errors include mismatched dimensions, so double-check your array shapes to prevent these issues. By being proactive and methodical, you can effectively troubleshoot and resolve broadcasting errors, ensuring smooth and efficient computations.
Broadcasting is not just a theoretical concept, it has numerous real-world applications. In data analysis and visualization, broadcasting simplifies operations like scaling and normalizing data. In image processing, it enables efficient manipulation of pixel data, crucial for transformations and enhancements. Financial modeling benefits from broadcasting by allowing seamless application of formulas across large datasets. Scientific computing, which often involves complex calculations, becomes more manageable with broadcasting, as it streamlines operations and optimizes performance. Finally, machine learning frameworks leverage broadcasting for efficient matrix operations, contributing to faster training times and improved model performance.
To make the most of broadcasting, adhere to best practices that ensure efficiency and effectiveness. Always check for shape compatibility before operations, using NumPy's tools to verify dimensions. Aim to minimize data duplication by leveraging broadcasting, which inherently reduces memory usage. Optimize performance by utilizing broadcasting for element-wise operations, avoiding slower Python loops. Maintain code readability by using clear and concise broadcasting techniques, which not only improve maintainability but also facilitate collaboration with other developers. By following these best practices, you can harness the full potential of broadcasting, enhancing both the speed and quality of your data processing tasks. In conclusion, mastering NumPy broadcasting can significantly enhance your computational skills, especially in data science and machine learning. By understanding and applying broadcasting, you can perform operations more efficiently, saving both time and resources. Broadcasting not only optimizes your code but also makes it more readable and maintainable. As you continue to learn and apply these concepts, you'll find that broadcasting becomes an invaluable tool in your programming toolkit. Thank you for watching, and happy coding!